All right, let's I guess get started then. So hello everyone, my name is Connor Nelson. I am the instructor for this course. I guess a little bit about me. I am a PhD student at ASU. I work closely with Dr. Adam Dupay, the guy that kind of created all the lectures that you've been watching, created the assignments. Um, I previously took the course with him back in 2017. And I TA'd the course with him in 2018. So I've got a pretty good understanding of all of the content, all of the assignments. And I actually helped him a little bit while he was setting up this Coursera in terms of the infrastructure of some of the assignments. So I've definitely got a good grasp on how things should be running certainly from an assignment perspective. I guess a little bit more about me. So this will be the first course that I'm the primary contact for teaching the course. So might make some mistakes, hopefully not too many, but if you don't like something that I'm doing, please feel free to let me know, give me some constructive feedback, and I'll try and improve on that. Another thing, let's see here. Yeah, so the other thing is, so we will be having the GSAs for the course. We have two of them. They'll be holding office hours. I guess the first one would have already happened yesterday at 11 a.m. on Tuesdays. And then I'll be holding this live event as well on Wednesdays at 4 p.m., which if you're here, you know that, of course. Okay, so I guess the question then is what's going to happen during these live events? So the TAs or the GSAs will be helping answer any questions or confusions or whatever questions you really have about either the material or the assignments. I will be doing a similar thing during my events. So if there's questions, please put them in the Zoom chat or feel free to interrupt me at any point and just ask, and I can try and clarify things. You can, of course, also ask those questions in the discussion group. It's kind of what it's designed to do. And then what else is there? Yeah, and then so the other thing is I might go on, I guess, slight tangents during this live event, kind of exploring concepts related to the assignments, kind of looking at various approaches you might take in the assignment, not necessarily showing you how to solve the assignment directly. But for instance, later on, there will be a module dedicated to binary analysis, basically cracking binaries. A very useful tool in doing that is using GDB. So for instance, something I might do during these live events is kind of give a walkthrough of GDB and kind of some of the powerful things you can do in GDB. And if you get familiar with GDB, that will make solving the assignments much easier. Or in the case of the web module, I might show some web tools, etc. Basically, do whatever we want during these live events, whatever is the most useful to everyone in the class is kind of the goal of that. So let's start by demoing, I guess, a few things. So since we're just in week one, there's not really a, hopefully not too difficult of an assignment. So right now you have the Makefile and Bandit assignment. Hopefully it's not too difficult for you. I guess if this is your first time working with Linux, you might be getting a little accustomed to how that all works. Okay, so I saw a question just directed at me. First day for course, intro and other stuff. I just joined a bit late. Yep, so you haven't missed anything important. Yep, just kind of an introduction to the course. Okay, so then, okay, so the thing about this week is that we're basically on the kind of super intro to the course, hopefully familiarizing you with Linux. If you have any questions related to that, feel free to ask, and maybe I can give general guidance on that. Again, we can't really give you direct, like, this is how you do it advice. It's not very useful. I mean, I guess it's useful for your grade, but it's not useful for learning. Anyways, so, but if you do have a question, please feel free to ask, and I can try and help you with that. In the meantime, I'm going to discuss some things about the course. Kind of thinking through, I looked at the course, remembered back to all of the assignments. And kind of one of the critical parts of it is the project CTF. So I will be discussing a bit about that. Might as well use the first week to do something productive. Get you all thinking about how the project CTF is going to be run and some of the details of it. The first thing though, let's just kind of get into a very brief overview of what is software security, the name of the class. And also just to make sure that I'm able to properly use Zoom and share my screen and do that. So we're just gonna test that out here. Okay, so we're gonna share screen, share that. And I think you should now be able to see my screen. Oh yeah, one more thing that I forgot to mention earlier. So a few people have already reached out to me asking various questions through email. The correct way to do that is to email mcsonline@asu.edu. I imagine this is the same for other Coursera courses, but maybe this is your first one. This is kind of the easiest way for everyone if you just email this email address. Anything related to the course will or maybe not automatically, somehow it gets to us, will be sent to us. And it'll be sent to both myself as well as the GSAs for the course, which means you'll have more people looking at the ticket, which means hopefully faster response times, etc. As I said, this is my first time teaching with Coursera. So this is definitely the recommended thing that they say to use. I assume it'll work great. I've already seen one person come through on that line. And let's just go with that for now. Ideally, yeah, send emails there if you have specific questions that I guess don't belong in the discussion forum, where discussion forum would be questions that are more general. And this might be questions very detailed, specific to the assignment about your confusions on something, or basically something that shouldn't be public. Okay, so the course is called Software Security. So let's just kind of, for a few minutes, kind of talk about what is software security? What is the idea of it? So the idea of software security is it's got two terms in it, right? We've got software, and we'll do this. And also I have a GitHub repo that I will be sending everything to, so you should be able to see this. I will upload anything that kind of happens during these live sessions here. It's already got the syllabus and it has a simple program that's kind of like a intro to the idea of software security that we will quickly go over during this, this event. Okay, so this is where you can find anything, and I'll also upload as I type this, these notes out so that you can refer to it later. So this is where you can find live event information here. Okay, so this course is called Software Security. So what does that mean? So we've got two words in that. We've got software and we've got security. So in my personal perspective on how I like to view this sort of thing is that software is all about making a thing do what it's supposed to do. Make thing do what it's supposed to do. So what does that mean? Obviously, it's kind of a weird way of describing software. What that means is that basically you're going to have some design idea in your mind, or maybe it's explicitly written out. You're working for a company, it's got design details on what needs to exist. We've got requirements on what needs to happen. And the goal is really just let's make this thing do what it's supposed to do. So I kind of view software from that angle of you're kind of building this thing out. And I look at security kind of as the opposite side of the coin. I look at security as make things not do what they're not supposed to do. They're kind of like intertwined opposites from the way that I like to look at it. So you have software where we're building a thing and we're making it do what it needs to do. And then we have security where we're doing basically not the opposite, I don't know, there's some logical term for flipping both. But basically, we don't want the program to do what it's not supposed to do. So what does that look like? So I designed a quick little C program called Simple Program. And it's got a Docker file. So I guess kind of side tangent. I highly recommend that you learn Docker. It's very useful, and it will also be at least slightly related to the Project CTF, which we'll kind of explain as we get later into this event. So if this is your first time seeing, hearing of Docker, I definitely encourage you to look into it. Docker is basically a tool that allows you to create these things called containers, where these containers are basically these standalone environments for creating your application. So rather than you've written a C program before and you compile it, now you have this binary, you run the binary. You can kind of think of these Docker containers as being both the program as well as their environment encapsulated into like one reproducible thing. And the keyword there is reproducible. It's extremely useful to do development, in my opinion. Maybe you have other workflows, but I think it's extremely useful to do development using Docker, because it basically means once you write it and everything's working, you've got this system that can basically be deployed anywhere. So this is our simple program that we're going to be looking at. I guess as a quick primer to Docker, though I encourage you to look into better primers. There's a bunch of directives in a Docker file. So the first thing is this like from statement. So we say like from Ubuntu 2004. So hopefully you're familiar with what Ubuntu 2004 or what Ubuntu is. It's a Linux distribution. And it's got a bunch of various built-in tools, etc. So for instance, it uses apt to install stuff. So then we basically direct it to update and install build essential. So normally, if you're doing development on your computer, at some point you will have run this command, or maybe it will have already been shipped for you in your Linux environment. And this is going to include stuff that lets you actually compile something. So for instance, this will include GCC, which will allow you to compile a C program, which is why we install it into this Docker container. Then we create this app directory. We say that basically we're going to work out of this app directory. We add the simple program.c, which is the thing we're going to quickly look at after I discuss this Docker file. We compile the simple program.c. We have this flag fno stack protector. This basically disables a security mechanism that you will learn about later in this course. I create this admin user, and normally you would put the passwords hash here, but I just put a basically secret information here, and you'll see why in a second. And then we say when we want to run this Docker container that basically this is going to be the command that gets run. Okay, so what does this simple program.c do? Okay, so hopefully you've looked at C in the past. It's definitely going to be highly relevant in this course. Yeah, so in fact, the next assignment you'll be doing is a backdoor web server, which I believe you're required to write in C. I could be wrong on that, but you refer to the instructions if not, or either way. So this is a simple program.c. This is what it does. We have our main function. It calls solve. And what does solve do? It basically sets up this answer variable, this question variable. It gets the question from the user. It computes the answer, not really, because we just kind of do it in this fixed fashion. And then it says the answer to whatever the question is this answer. Okay, so what does it look like when we run that? And also, I guess, as a further demonstration of Docker. So when you want to use Docker, okay, so I guess the first thing to show would be how you can install it. So you can wget o dash, this is like the standard way that I do it, though people will complain that you should never do pipe into sudo, oops. How did that just fail? We get o dash get docker io. So people say you shouldn't do this like sudo sh thing, and there's technically security reasons that you shouldn't do it. But if you're just got a brand new system, you want to quickly install Docker, this is a simple way to do it. Either way, though, I would look into guides on Docker. This is how you can install it. And then, so the first thing you would do with a Docker file is you need to basically build it. So we do this Docker build, simple program. Basically, this -t is saying what to tag the Docker container as. So this went through and executes all of these steps within that Docker file we were looking at. And then successfully tagged it as this. Okay, so then now if we run it, we can see what the program does. So we can say that if I tell it my question, it'll basically say the answer to my question is 42. If I say cool, the answer to cool is 42. So it looks like we've built out this program that we wanted to build. You know, if we look at it from this software security perspective, where I said the software is making a program do what it's supposed to do, we've maybe achieved our goal, assuming that the goal is to write a program where it answers 42 to whatever your question is. So that's awesome, right? We built the program, we're good to go. Let's ship it, let's deploy it. This is an awesome application. It's amazing. Why would people not want to use this very advanced tool that will answer any question, of course, with the answer 42. We've basically hit our design goals of what we wanted to do, what we wanted to accomplish. The issue, though, is the security part of this course, right? This is what we're learning about, security. The issue is that this program actually does potentially a lot more than what we seem to have explicitly told it what to do. And as you'll learn in a later module, this gets function has some issues. If you sit down and you start to deeply understand how this program is actually running, basically what the stack setup is, all of the assembly instructions that are running, the actual underlying principles of how this program gets executed, you begin to realize that there's a problem here. And the problem, and we're not going to get super into it because it's the first week and this is a later module, but I want to kind of just dive right in and look at what software security is. The problem is that this program can do more than just say the answer to blah, blah, blah is 42. So we'll see that there's this function, nobody calls me. And if you quickly scan through these few lines of code, you'll see that in fact, nobody calls it. So if I search nobody calls me, yeah, no one, you can very quickly see that nobody is calling this function. But what happens when we do the following? If we say, oh, now I gotta remember, hold on, let's look at our ultimate question.txt. What happens when we Docker run this simple program and we say question of life, universe, and everything? What happens when we tell the program that we want the answer to this? It does something insane, right? The code doesn't say anything about how this could ever possibly be called. It literally is called nobody calls me, and you can definitely verify, yeah, nobody calls me. And we can see that just inputting this into my simple program that's designed to answer with 42 to anything. And in fact, here it doesn't even answer with 42. So I guess maybe you'd say we didn't technically achieve our design goals of always answering 42 to a question. And for some reason, it seems to have like mangled our question up. Something insane happened, right? And in order to understand security, you basically have to deeply understand what a program is actually doing, what is running under the hood. So if I look, I guess, into the hood, like very briefly here, we can run a tool like objdump, and you'll learn more about this in later modules. I won't worry too much about the very specifics of this. We can see that we can start to look into the actual compiled code, what the C was generated into these machine instructions. And there's a set of memory, and there's all sorts of things at play in all of this. So we can see, for instance, that, let's see here. Gotta scroll a bit more. It's a little confusing with being all zoomed in with this text. A little bit further. Yeah, so we have like this nobody calls me function. We've got our main, and we've got our solve. And I'm not going to get into the very specific details, but what I'm trying to say here is that there's this C program, but fundamentally, that's not the entire picture. In order to understand security, you need to understand all of the details of what's going on with your program. So you can't just understand like, oh, hey, this is C, this is going to let us like take some user input. This is going to let us output some stuff. You have to understand what that is actually fundamentally going to do on the system and how it's going to execute in order to be able to start to understand security. And kind of that's, in my mind, like the whole idea of hacking. So people say like, oh, some people say like, oh, hacking is bad or whatever, like bad people are hackers. But really the way I view it is that hacking is about really getting to deeply understand a topic. And I think that as we move forward through this course and you start to more deeply understand some of these concepts, that'll become more apparent. So anyways, let's look again at this. So what happened here, what happened here when we did this input here? Somehow, even though nobody calls it, it still got called. And you'll learn in the binary module how this happens. But clearly security is important, right? If you can't have programs doing this, right? I think anyone would very clearly say like, yeah, this is not what the program was designed to do. Even if you laid out these design requirements and said, hey, I want to basically answer 42 to any question, and that's the only design requirement, it's very clear that if we were to actually go through and understand what the program's not supposed to do, like with human intuition, right? This is something it's not supposed to do. This is a security issue. Because suddenly, this program that's just supposed to say 42 to any of our questions is suddenly spitting out the contents of Etsy Shadow and leaking all of the passwords or hashed passwords on the system. So hopefully that kind of gets a nice primer into what software security is all about. And of course, this is just, in this case specifically, like binary security. We're also going to be looking in this class at network security. Network security, let's go back to this. So the topics covered in this course, we're going to be looking first at network security. Then we will be looking at, I guess I'd say binary security, maybe there's a better word for that. And then we will be looking at web security. And going off, I guess, continuing with that example, we're going to have several assignments in this course. So if we quickly switch over to the Coursera here. Yeah, so currently you're working on or have already solved the Bandit assignment. The next assignment will be a backdoor web server where I believe you write C. I don't know if you're allowed to use any programming language. In some of the assignments, you can use whatever programming language you want, really. I believe this is in C, but the document describing the assignment will definitely clarify that, where you basically write out an HTTP server. So you can kind of, and I guess in this case, a backdoor web server. So you can kind of think of this as going along that similar vein of like what hacking is, where hacking is really trying to deeply understand something. In this assignment, you'll basically be given the RFC document of HTTP, and you have to implement a subset of it to construct an HTTP web server. In doing so, you will become very intimately familiar with how HTTP works. You'll actually understand the underlying protocol that makes the whole World Wide Web work that everyone uses on a frequent basis. So that should be a fun assignment. In the third week, we will have this crack the password assignment where you will be given a binary and you will have to go through and reverse engineer it to understand, I think it's basically, there will be some input that if you give the binary that, it says like, hey, this is correct. And the goal of that assignment will be fundamentally understanding x86 64-bit assembly and being able to look at that, at least a basic program, and understand what it's doing. So again, with that hacker ethos of kind of truly understanding what stuff is about. The next assignment will be the reflector assignment, which is a network security related thing, where basically you will be required to implement an ARP spoofing and IP spoofing attack. So again, you will become very intimately familiar with how these protocols work. Then there is the midterm. We've got then the binary hacking assignment, where basically you'll be given 10 binaries. I think you can do up to 15. I don't know, maybe those are just like extra for fun or whatever, but I think it's like 10 binaries, and they'll be similar to the example that I demoed here in some ways, where basically you're given the source on, I think you're given the source on some of them, and you'll have to like look through, figure out what the security vulnerability is. So for instance, in this case, like this is bad, this gets thing. In fact, you can actually see that if I make it so it'll recompile this, if I do the Docker build again, you can actually see that like the compiler even like says like, hey, this is really bad, like just don't use this. So this would be a very not good thing to use. So potentially, for instance, one of those 10 binary levels in that assignment would use gets, and then you'll have to figure out how to abuse that to do what needs to be done, where doing what needs to be done is basically elevating your privileges. You do that by running a particular program. So I think on the system, there will be basically this like leet program. So it doesn't exist on my system, but basically you want to call that leet program, even though the program is not designed to call that leet program. And as a result, you've solved the level. It's basically the idea. And that, hopefully that'll make more sense once we actually get into that module. Just kind of giving a high level overview of the class. Okay, so that will be this binary hacking assignment, and the techniques used will be, of course, covered in the lectures and so on. Then we have web security. I think it'll be basically similar to that binary security thing, this binary hacking assignment, but instead of 10 binaries, it'll be like 10 websites, and you need to exploit some web-related security vulnerability within the website to get to the next level and solve it and get credit. Okay, so that's the assignments for the course. The last highly critical thing, potentially the most fun thing in the class, is this PCTF assignment, or I guess PCTF project. And as part of that, you will be broken up into teams, and you will compete in this game thing. What is that game thing? So if we, let's quickly, how do we want to look at this? I guess the first thing I'll point out is that you can find the infrastructure. I don't know if you really are that interested in the infrastructure of the game, but maybe it'll be able to answer questions you might have about PCTF, but it's basically based off of this ICTF framework. So if you have questions as we get further into the class, obviously you can ask, but if you really want to get down into like, how do things work in this game from like a infrastructure perspective, maybe you'll find this interesting. But you certainly don't have to look at it. I'll include the link though in this document, just so it's there. PCTF framework based on. I think we might have some very minor changes to it. Okay, so what is PCTF though? So PCTF is a project capture the flag. That's what it stands for. Project capture the flag. So capture the flag, I guess, would probably be the logical first thing to try and understand, is a security game. So capture the flag, security game. And the objective in capture the flags is basically to, as the name implies, capture the flag. And how you do that is by abusing some security related issues in a challenge. So there's two main types of capture the flags. There is Jeopardy style capture the flag. Capture the flag, say that. And then there's attack defense style capture the flag. So in this one, this will basically be how the, what is it called? binary hacking and web hacking assignments will look. Binary hacking assignment, web hacking assignment. So they basically model the Jeopardy style of capture the flag, where you are given some challenge binary and you abuse it into giving you the flag, or in this case, abuse it into giving you Coursera credit. So that's kind of the idea of Jeopardy style capture the flags. It's just a challenge. And then there's going to be some secret, for instance. So I guess what we could also say is Bandit is a Jeopardy capture the flag. So it's just like that, basically, but scaled up in whatever direction you want to go with it. So that's the whole idea of a Jeopardy style capture the flag. Whereas on the other hand, attack defense style capture the flags is a bit different. So you're given some system connected to the game network. There are several rounds. Each round is like 3 minutes, well, at least certainly in the case of Project CTF, though most attack defense CTFs that are run follow pretty similar philosophies on how it's run. Though, of course, you could vary this 3 minutes however you wanted. In the case of Project CTF, each round is about 3 minutes. So what happens during these rounds? What's the objective? What's the goal? So you want to attack and you want to defend, of course, as the name implies. So what are you attacking? What are you defending? So when you're given this system connected to the game, maybe that's not useful, right? When you're given the system connected to the game network, your system runs some number of vulnerable services. And what are those vulnerable services? They could be basically anything. In this case, it'll probably be either, it'll be related, of course, to the assignments that you work on, but it'll be some program that's running, and it'll be running on a networked, over some networked connection. So basically, the service exposes some port to the network, and all of the teams can connect to that service. So we have, if you're on team 1, you can connect, of course, to team 2 or team 3 or team 4's services. So maybe this is getting a little confusing in terms of how I'm saying this. So the service exposes some port to the network. What else is there? Oh, right, of course, the most important part, the flags. Okay, so so there's several rounds, I guess I think they're normally called ticks, several ticks, we'll say rounds. Each tick is approximately 3 minutes. In a tick, the game will connect to each team's system for each service, and it will interact with the service. In doing so, it will exercise functionality of the service, and it will also create a flag. So there is a unique flag in every single tick of the game. And your goal when you are the goal is to capture another team's flag for some service. So this is the objective. And if you want to defense, prevent other teams from capturing your flags. Hopefully makes sense there. So how do you do that? Well, you patch your service. You find and you identify the vulnerability and you patch it so that they can no longer exercise that vulnerability to steal your flag. So you patch your service, then they can't steal the flag. Okay. But what stops you then? Maybe you might be thinking, okay, so the most secure system is going to be one where we just take everything down, right? Let's just make it so the service does nothing, and then of course they can't steal the flag. The issue with that line of thinking maybe is that there is, as we said before, in doing so, it will exercise functionality of the service. The game will verify the service still works to do required functionality. So you can't just bring the service down. It has to be able to still function. All you're allowed to do is patch out the vulnerability. Okay, so maybe a bit more information on that. So maybe there's, and of course, as you have questions throughout the semester, always ask. I'm just trying to make the most of this first session by getting as much information out as I can. Okay, so this is the project CTF. And oh, there was one more thing I was going to say about this. What was it? Game will verify the service still works to do required functionality. Oh, right. So I guess maybe a natural question might be, well, how does it create the flag? Can't I just like identify flags and like delete them, but still make the service function or whatever? It's built into how the service functions. So for instance, I think the easiest way to explain this will be with an example service. Example service. So you can imagine some program where it takes a, maybe you send it your username / password, and it reports your mail. Maybe it's some mail client service. Okay. Well, the question then is, how does the flag fit into this? Is the mail the flag? So normally, under normal operation, and you could design it however you want. In the case of the PCTF, though, is that there is a flag identifier, and then there's the flag. So in this case, the flag identifier would likely be the username. The flag could be maybe the password or sensitive mail or something a random person cannot access unless exploited. So you can imagine that the game will come in and it will exercise the functionality of your service. And in doing so, maybe it creates a new account. It will, using some flag identifier, construct the username, and it will set the password to be the flag, basically. Well, when you go as a normal person and you interact with that service, you're not able to just like steal a random person's password. That doesn't make any sense. That would probably be considered a security vulnerability. But what you can do if there's a vulnerability is steal that password. So that would be capturing the flag. And what you'd want to do is do this every single tick. Every single tick, the game will go through. It'll basically, like in this case of this service, would create a new account with a new username, a new password. You would know, so I guess something to continue to point out. You know this. So the game infrastructure will report to you all of the flag identifiers for a particular service for all of the opponent teams. So you know what you're after. So if you know that you're trying to steal users' passwords, and that's the objective in order to get the flags, you will know what the usernames are of those users that you're trying to steal the passwords from. The game will tell you, hey, these are the usernames you need to steal the passwords from. What are the passwords? And if you get the passwords, you get points when you attack. And of course, the defense will be like, hey, did anyone steal any of your passwords? Did someone else submit a flag for your service? Okay. So you know the flag identifier. In this example, it might be a username. In this example, the flag might be the password of an account. Okay, so this is a long rant about what PCTF is. This is what the big project of this class will be. It's this project CTF. And what you will need to do once you're assigned your team is basically just go and design a tool that helps you play this game. So there's a number of things that are going to help you. So the most obvious thing that will be absolutely critical useful things, and you'll want to think a lot about what will help you, and that's kind of like how we'll be grading you on this project is, yeah, that makes sense, that looks useful. Maybe it didn't pan out, for instance, but it looks useful. So some things that are useful in this game. So you may have your exploits, but you need to run them every single tick. Something that you want to succeed in PCTF is you want an exploit thrower. You want something that can pull the state of the game, check to see if there's a new tick, ingest all of your new flag IDs, and then run those exploits against all of the targets and capture the flags and automatically submit it in. This streamlined process of doing that is commonly referred to as an exploit thrower in attack defense CTS. This is something that would be, for instance, extremely useful. Basically critical, unless you want to be running this sort of attack manually every single tick, which sounds kind of crazy, but I mean, yeah, you want something like this. So this is something you would like infrastructurally want. The goal though of PCTF in terms of the project, so you'll spend some amount of effort creating something like this probably, but you'll also want to create some sort of security tool. And it's kind of hard to say what you want. It's as we get later into the class, you'll kind of maybe hopefully develop some intuition. The reason I'm presenting all of this information about the PCTF now is just so you have some idea of what it's going to look like. If I was taking this class, I think it would be useful to know about the PCTF basically right away, so that you can start thinking about maybe some general strategies about how you might go into this, etc. And if any of this is super unclear in terms of how I've described this, there's going to be lecture videos that describe PCTF more in depth. I think the primary one that kind of goes over like the game being played is in like week 6. But I just wanted to introduce you to the idea of PCTF really early on in this class. And I figured since the first week, there's just the bandit assignment, which is much easier than the other assignments. Figured we could just quickly dive right into this PCTF to get you kind of thinking about it for when you go and create your projects. All right, I'm going to stop sharing the screen now. I'm going to look at the Zoom chat and see, yeah, I probably should have been looking at the Zoom chat earlier a bit more. Okay, hold on. For some reason, my Zoom doesn't show any of the people in here. I don't know what happened there, but my webcam says it's still on. Just to verify, can you still see me? Can someone say in chat, like, am I still visible?
Yes.
Okay, awesome, great, thank you. Okay, so I can't see you guys anymore. I can see the chat though, so I guess that'll be sufficient. I can hear your voices, so we'll just go with that. Okay, let me look at the chat, which I probably should have been doing throughout this all this rambling, but let me quickly look through it and see. Okay. Are we allowed to try to take down other team services? Yes and no. So you're not allowed to do like a boring network DDoS. Like you're not allowed to just like spam them with packets until their system is just overwhelmed and can't process anything. That is definitely against the rules. But depending on how the services are designed, it's possible, for instance, maybe there's some critical file to the running of the service, and for some reason you're allowed to like delete that file. If you can do that, you're allowed to do that.
I was thinking along the lines of if I took down their service and replaced it with my own, such that every time they got their flag, it just transmitted directly to me, that would be even better.
Yeah, definitely. If you're able to do that, that is definitely allowed. I would be surprised if any of the services that we design certainly intentionally allow that vulnerability. But if you can get that done, yeah, definitely that would be more than allowed. Pretty much just about anything goes, barring like just overwhelming their system resources to like make it so they can't process anything, and then the system isn't able to interact with their service. So it says, oh, it's down. You know, we don't want anything like that. That's definitely against the rules. But pretty much anything besides that is like more than welcome. If you have like a idea that you're thinking of that maybe sounds like, maybe in your mind, maybe like, oh, is this unfair? Feel free to ask. But basically anything goes. Yeah, so for instance, like if you're able to get persistent access on the service, so the services will be running using Docker Compose, which is kind of a way of composing Docker containers. I think even though it's Docker Compose, I think it's only gonna be running a single container. Maybe some of them will have like database containers or something. But for instance, if you're able to get arbitrary code execution, something that will be discussed in some of the modules, if you're able to get arbitrary code execution and you just have a shell sitting there and you like persistently, and even if they patch it, your shell is like still there, though they could Docker restart you to kick you out or whatever. But if for whatever reason you have a persistent shell and you want to just like sit there and just like pour out all of the files and like figure out which ones are the flags, like go for it. That would definitely be like a super vulnerability that you could take advantage of. Maybe, I guess now I'm thinking about this, like maybe part of your defense strategy might be to periodically restart your Docker containers, even though, I don't know, it doesn't sound like necessarily a super great defensive strategy, but I don't know, something to think about. Okay, so a tool in this sense may be a script, aka exploit thrower, that runs standard tools like Metasploit as systematically and quickly as possible. Okay, so something to note out with that question is Metasploit. So Metasploit is very unlikely to be useful for you here. So Metasploit generally, if you have, Metasploit is designed as basically this collection of existing vulnerabilities for specific real world software. And it like just goes through and runs that exploit against that real world software. Maybe, I don't know, it figures out if it's vulnerable. If it is vulnerable, it runs the exploit. In this class, everything is going to be custom designed software. So I would be very surprised if you really get any use out of a standard tool like Metasploit. That being said, there will probably be other standard tools that are more low level that you'll find useful, or you might find useful, and you're more than welcome to use that. That being said, you can't just use some pre-existing tool and like say, hey, this is our tool for PCTF. We're looking for you to put some work into and like think about and develop a strategy and like kind of a sense of what this tool is designed to do. Yeah, basically you can use other tools as part of your solution, but you need to like ultimately still be building something. Even if it is potentially like gluing things together and doing this, there's all sorts of options, but I think there will be at some point, one of the assignments will be like proposing your ideas, and we'll be looking through that to make sure that everything is like kind of what we're thinking about, everything looks right. Okay, are the vulnerabilities that I'm having in my service the same that other teams are having? Yes, so initially everyone will be running the exact same software. So you'll likely one of the first things you'll do once you're given access to your game box is go through and just basically back everything up. So you have an understanding of the initial state of everything. And what this will allow you to do is that say you go through and patch your service, if you go through and patch your service and it determines, the game infrastructure determines, hey, this is no longer functioning as it's supposed to do, you'll have something that you can back your service up to, or that you'll be able to revert back to start getting your availability back online, which is part of your points. And what else was I was going with that? Oh, and yeah, so everyone's starting with the same software. So like when you're analyzing, looking for those vulnerabilities, you'll go through and likely patch it on your end, but also you'll abuse that vulnerability to create your exploit to attack the other teams. How long does the game run? Okay, so my understanding, this is still something to be worked out, I guess. I looked at the document for it and it said at least 24 hours. So I haven't decided yet, and I'll decide, I guess, kind of a little bit later into the semester what makes the most sense. It'll probably be either 24 hours or it'll be 48 hours. I'm not sure which would be better. I'll have to think more about whether 24 hours being a shorter amount of time, which means you don't have to like worry about and manage and stress about it for longer, is worth it, or like maybe 48 hours is better because people are all over the world with different responsibilities and have different time options, and maybe it's more useful to do 48 hours because you're kind of basically expected to play for at least 8 hours, and if it's 48 hours, now you have a bigger window to play that 8 hours in. So that's something I have to work through and kind of think about. So yeah, it'll be either 24 hours or 48 hours. Where to find the recording of today and yesterday? So the recording of yesterday hopefully should automatically end up on Coursera, because I think that, I don't know, it'll be on Coursera. It's not on Coursera. Okay, so I will have to look into that. But ultimately all the recordings will end up on Coursera. I have to look into that a bit more because, like I said, this is my first time teaching Coursera, but my understanding is that the standard is for all of these live events to just be like posted on Coursera. So I'll figure out how that gets done, and that's where they'll be. But the notes that I kind of wrote down today for my presentation, I will upload to GitHub, and I'll create like an announcement or something with the link to that so you can see it again, but it's at my GitHub. Okay, is every team attack defense, or can we do Jeopardy style? Yeah, so for the PCTF, the entire game is an attack defense CTF. And maybe, I don't know if I'm reading into this question the wrong way. You are both the attacker and the defender as a team. So you're doing both the attack role and the defense role. So I know there's some like collegiate competition where you're like just the defense. That's definitely not how this is. You're both the attacker and the defender. As for the Jeopardy style, some of the assignments will be more along the lines of a Jeopardy style. So the binary exploitation assignment and the web security assignment are like basically the Jeopardy style. Okay, yeah. So are there any more questions before I start wrapping up this first live event? I'll ask if each tick to be, oh, I missed that. Yeah, you're right. Would each tick be a different service? No. So in some attack defense CTFs, the services are like slowly released and then retired. So for instance, in DEF CON CTF, which I believe there's like a bunch of videos in this Coursera about, the style of the DEF CON CTF is an attack defense CTF. And how that works is basically at the beginning, maybe there's 3 unique services launched, and then periodically some of those will get retired and new ones will start up like after like 8 hours or something. In the case of this class, I believe, and I'm not 100% sure, but I'm almost certain that we'll just have all of the services up at the start and they'll just run the entire time. So yeah, it doesn't like every tick isn't a new service. It's more so the case that every tick is a new flag. And the reason that it's set up in that way, that where every tick is a new flag, is because we want to, the way you're scored is basically, in order to introduce this defense element, right, we need to be able to say like, oh, hey, you finally, or not, maybe not finally, but you figured out how to patch this service. So if you get that done really quick, you know, you get more defense points because you patched really quick, for instance. So yeah, every tick is the same services. Okay, is there any more questions? Are we graded on points? So I believe your performance in the PCTF will be a component of your final grade. I'm not exactly sure how that'll work out. So the majority of your PCTF grade will be based on the tool that you create and the kind of ideas going into that tool, like kind of how you're thinking about your strategy approaching the game, how interesting the tool is, how much work it looks like was put into that tool. But I think also a portion of the grade for the PCTF will be your performance in the CTF. That being said, for instance, if it looks like everyone is just like going all out and this is this crazy competition, but your team ends up in like last place, if it's like this crazy competition and you're like clearly like trying like real hard and like going after it, you're not going to be like aggressively penalized for that. On the other hand, if you like slack off and basically just like don't play the PCTF, you're definitely going to lose points for that. So your performance in the PCTF is some portion of the project CTF grade. Yeah, that's kind of what I would say to that. Any more questions? Now I'm even more confused. Now I can't even see the chat. So I'm going to assume there's no more questions. Something went wrong with my Zoom here. So it's going to be interesting on how I figure out how to, oh wait, maybe that's the button. No, but that doesn't do anything. Yeah, I don't know. I have to look into Zoom a bit more. I've been using it for the last year, so I don't know why it's suddenly deciding to give me issues. I'm just going to like force quit Zoom and hopefully that ends the meeting. But yeah, thank you all for attending my first Zoom meeting. If there are any more questions, please feel free to either post them on the discussion forum or reach out to us through that mcsonline@asu.edu email. All right, thank you everyone. See ya.